this example, we have the system of two equations. As the first one, dx dt plus dy by dt equals e to the power t. And the second equation as negative second derivative of the x with respect to t plus dx dt plus x plus y equals 0. Use the operator d as d of the x variable is the same as dx dt, and d of y is the same as dy by dt. D square x is the same as the second derivative of the x with respect to t. Note that x is a function of the t and also y as a function of the t. So t is the independent variable. Next, we're going to rewrite the equations into the form of the operator d and write it in the systematic way. So the first equation, we have dx plus dy equals e to the power t. Second equation, we have negative d squared of the x plus dx plus x and then plus y equals 0. And group them in the form as for the second equation in the form of the quantity negative d squared plus d plus 1 times x plus y equals 0. And next we are going to eliminate the variable y. To eliminate y, we have to get rid of the y by making the same coefficient but opposite in sign. So the first one, the first equation, we do not do anything but just multiply the second one by the operator d with the negative sign in the front. Therefore, we obtain the equation, the second equation as a form of d to the third minus d squared minus d multiplied by x minus dy equals 0. And the first equation remains the same as dx plus dy equals e to the power t. And we can see that the dy and minus dy cancel out. Now, after we add these two equations, we have d to the third minus d squared minus d of the x plus dx equals e to the power t. So rewrite it as d to the third minus d squared minus d of the x plus dx equals e to the power t. And expand them out to be d to the third of the x minus d to the second of the x minus dx plus dx equals e to the power t. Minus dx and plus dx cancel. Note that d to the third x is the same as the third derivative of the x with respect to t, or x triple prime. And d to the second x is the same as the second derivative of the x with respect to t, or x double prime. So this becomes the equation, the differential equations of the x as x triple prime minus x double prime equals e to the power t. And this is the linear third order and non-homogeneous equation. So we're going to solve for x using the undetermined coefficient. So we're going to find xc and xp. As xc, the complementary solution, xp is the particular solution. To find xc, use the associated homogeneous equation as x triple prime minus x double prime equals 0. And the auxiliary equation that we're going to use to find the solutions would be m to the third power minus m to the second power equals 0. Factor completely to get m squared multiplied by m minus 1 equals 0. Or m equals 0, 0, and 1. So we have repeated solution 0. Therefore, the Xc or the complementary solution would be the linear combination of the X1 would be the e to the power 0t, X2 would be e to the power 0t. Actually, this is 1 and this also 1, and X3 would be the e to the first power times, e to the t. All right, since x1 and x2 are repeated, so to make it linearly independent from each other, we have to multiply by another variable, which is the t in there. So then the linear combination of x1, x2, and x3, it will be in the form of c1 multiplied by 1 plus c2 multiplied by t and plus c3 times e to the t, or just xc equals c1 plus c2 times t plus c3 times e to the power t. And next, we're going to find the particular solution xp. So from x triple prime minus x double prime equals e to the power t. And also the xc equals c1 plus c2 times t plus c3 times e to the power t. As from x1 equals 1, x2 equals t, and x3 equals e to the power t. As we see the non-homogeneous term, or the e to the t here, we're going to use that to find. So we're going to find xp from the gt, or the non-homogeneous term, as e to the power t. E to the power t for the trial solution would be in the form of xp equals the a times e to the t. But to check with the existing solution from the complementary solution, x to the power t is repeating with e to the power t is the same as e to the power t, which is the solution, one of the solutions from the complementary solution. So we have repeated case, repeat solution. Or if you recall in 4.4, this is called the case number 2. So then we have to multiply the solution, the trial form of the solution xp, by multiplying by another independent variable t in there. So now our xp is a times e to the power t times t. And since we claim this is the solution, this solution xp must satisfy the same differential equation, which is x triple prime of the subscript p minus x p double prime equals e to the power t. So then on the side notes here, we're going to find out what are x p prime, x p double prime, x p triple prime. Using the product rule for the derivative, so we get a times t e to the t plus a times e to the t. And the second derivative, we will get a times t plus 2 times e to the e to the t. And the third derivative, we're going to have a times t plus 3 e to the power t. You can do more details, but this is a quick way that I look at my notes. So we have x triple prime, double prime as it is. And then we replace x double prime and triple prime into the differential equation, and then use a method of undetermined coefficient. So x triple prime, which is a times t plus 3 times e to the power t minus the double prime, or a t plus 2 e to the power t equals e to the power t on the right hand side. And since both sides has common the common factor as e to the power t. So then we have a as another common coefficient, and multiply by t plus 3 minus t minus 2 equals 1. T and 3 reduce, so we have A equals 1. Therefore, the particle solution for the x or the xp will be in the form of t times e to the power t. Okay, and next we put them together as x equals xc plus xp. Xe is C1 plus C2 times T plus C3 e to the power T, and then plus Xp, which we just found, or T times e to the power T. And then we're going to find out what is the Y solution.